Hello and welcome to my video on Chapter 3 and 4, Lesson 4, the Basics of Logarithms. So here we have this idea of logarithm, which is a variation of a power. And so logarithms are simply the final version that we haven't looked at until now. And so we're going to take a look at the three different versions. So first of all, we have powers. Okay, powers follow the normal rule that we're used to. Base exponent equals an answer. So 2 to the exponent 5 equals 32, for example. And powers are something that you've learned about for many, many years, at least grade 9, but you've probably even seen squares and cubes prior to grade 9. Okay, so then we can continue that and we can talk about radicals. Radicals are something you learn about in grade 10. In grade 10, we learn about the square root, cube root, and even other types of roots. And prior to that, yeah, you may have heard of radicals, but in grade 10, you go into further depth. And so radical is just the rearranged version or the opposite operator of the power. You can see that it uses the same three numbers, but in a different order. And so the radical allows us to solve for the base. The power solves for the answer. And so the last one that we need to be able to solve for is the exponent. And a logarithm allows us to solve for the exponent. So a logarithm changes this again. So this is a log base 2 of the answer equals the exponent. And so you can see that all of three of these are the same three numbers, but solved for a different part. And so this is what I call the basic definition of a log right here. And this is very, very important when we look at everything for the rest of the unit. For any time we're talking about a log, the basic definition of a log is usually going to come up in almost every question. And yet people forget about it all the time. We look at laws of logs later, and those get more complicated. And so when it gets more complicated, we forget about the more simple one. And the simple answer is this: the basic definition of a log. This is not in your formula sheet. This is something you need to memorize. It's what a log is. It's the definition. It's what it means. So we're going to use that definition in order to solve for some of these questions here. So I'm going to do the first one, and then I recommend you try the second one on your own. So this here, we're going to say we're trying to solve it, and we're going to call it x. We're trying to solve for x. We're trying to see what log base 3 of 27 is. So what we're going to do is we're going to rearrange it into an exponential function, or equation, or expression. I guess the equation in this case. So 3 to the x equals 27, because it's just the rearranged version of what we saw with the log. Log equals the exponent, and now the exponent is our x. So now we're going to use our common base idea from the last video. And so, whoops, that's not an x. 27 is 3 to the 3. And so because they have common bases, we can get x equals 3 as our final answer. Okay, so we're going to try this again here. I recommend you pause the video now and see if you can get the same answer I do. Okay, so what we're going to do is go 2 to the x equals 256. Now this is fine and great, but you probably don't know 256 off the top of your head. So what we're going to do is we're going to slowly divide by 2 over and over and over again until we get down to the number 1 or the number 2. You can kind of stop in either place. Okay, if you start with the number 2 here, you can go that's 1, 2, 3, 4, 5, 6, 7, 8. So this is 2 to the 8. So I don't have it memorized, but I can divide by 2. And so this number, 256, actually any of these numbers that you can see here, as well as continuing on to 512 or 1024 or 2048. All of these numbers are numbers that you've probably seen before in the context of cell phones or computers, storage, RAM, that sort of stuff, because these are all binary numbers, like numbers that are base 2. So whenever you see one of those, just think, oh yeah, this is probably one of our base 2 numbers. Okay, so this finally tells us that x equals 8. Okay, so now we've got 2 alternate examples down below. I again recommend you pause the video now and see if you get the same answer I do. So in this case, what we're going to do is say 5 to the x equals 1, and anything to the exponent 0 will equal 1. So that means x is 0. And so this is the general rule that if you have an answer of 1, the exponent must have been a 0. Okay, the nice thing is we have one more rule that we can also learn/memorize. 8 to the x equals 8, which we will change to 8 to the x equals 8 to the 1, which means x equals 1. So in this rule, if the base and the, I guess I did that wrong, the first one's the base, and the answer are both the same, then the answer must be a 1. The exponent must have been a 1. Okay, so we have all these different logarithms that we've solved now, but now we're going to solve some exponential equations using logarithms. So before we were solving logarithms using exponentials, now we're going to use logarithms to solve exponentials. Okay, so what we're going to do is simply rearrange this into the logarithmic form, and then we're going to be using our calculator. So this is log base 3 of 32 equals x. Then we can plug into our calculator. So there's 2 different ways. I'm going to show you both ways. This one here, so log base 3 of 32, and we get 3.15. And that's our final answer. But there is another way of doing this. So if you have a fancy calculator, like a TI-84 plus CE, or without the color edition, then you can do what I just did. So math, go up to log base, and you're good to go. But the other way you can do this is, well, you won't have a fraction button, but what you can do is you can do log of 32 over log of whatever the base was. And it gives you the same answer. Now, I guess for you, you would write it like this. Okay, so if you don't have the log base option, all you have to do is put the log on the denominator, like divide by that log of the base, and that is how we can change the base. So we're going to look at that more in the next lesson, but just so you guys know, that is how that works. Okay, let's keep going here. We're going to try the next one. I recommend you pause the video now and see if you can get the answer. Okay, so this is going to be log base 5 of 100, which equals x. And so now we just need to plug this one in. Whoops. So math, and then you go up 3 times, and then you just type it in. It's going to be 2.86. 2.86. Awesome. Okay, let's keep going. We're going to see another couple examples. We're almost done the video. We've got this one here. Now, this one is a little bit odd. But what we can do is we can evaluate this part in green and then get our answer. So what we're going to do is just look at the green part and change it. So it's 4 to the x equals 64. So 4 to the x equals 4 to the 3. Is that right? 4 times 4 is 16 times 4 again. Yep. So x equals 3. Now our final answer is actually going to be 3 times the thing inside the brackets, which is a 3. So our final answer is 9. Okay. So we can just evaluate the log individually. So if you try this example, pause the video now and see if you get the same answer I do. Okay, so we're going to do this part first in brackets in red. We're going to do that first. We're going to say 2 to the exponent x equals 16. So 2 to the x equals 2 to the 4. So x equals 4. So this is 2 to the 4. Now what was 2 to the 4? 16. And so our answer is 16. So this one's actually an interesting one. Because if you have log, sorry, I did that wrong. If you have some sort of base to the exponent log of that same base, and then you have a number, whatever number that is going to be your answer. So this part cancels. So that's an interesting thing to notice. But if you're ever unsure, don't worry about it. Just simply do the log individually, and then you can always plug it back in after. Okay, last two questions to try. We're going to determine the value of x in both of these. So in this first one, what are we looking for? Well, this is the answer. So then what we're going to do is we're going to change this. So it's base 3 to the exponent negative 2 equals x. So it's going to be 1 over, I guess I'll put it over here, 1 over 3 to the 2. So it's 1 over 9 as our final answer. Okay, you can try pausing the video now and seeing if you get the same answer I do on the next one. Okay, so this time we're looking for the base. Which of our different options lets us solve for the base? Well, that would be if we have a radical. So the inside is the answer, and then the exponent goes here, which is the 2, so it's a square root, so that one can just not be important. Like it is a square root, but the 2 is kind of invisible. And so square root of 49 is 7. All right, so I hope this video helps you better understand logs in all of these different contexts, but most importantly, as I highlighted at the bottom of this screen right now, the definition of the log in yellow. I hope the video helped, and good luck.